Hey team, Joshua Roney here. I'd like to go over some training on testing for generator batteries at your hospital. Per the 2012 edition of the Life Safety Code, maintenance-free batteries are now permitted to be used in hospitals. Per NFPA 110, year 2010, section 8.3.7.1, states that you can test the batteries by measuring the electrolyte specific gravity or by a conductance test, whenever applicable or warranted. Since access to the electrolyte is not available on maintenance-free batteries, a conductance test is to be performed. One of the questions is how to perform that conductance test, which is required once per month. Using a battery conductance tester, which is not a voltmeter, connect the two test set leads to the positive and negative post of the cell or battery under test. There is no need for additional leads to be connected to the ends of the string or for a clamp-on current measurement. A conductance measurement is displayed in Mohs or Siemens. Now, how do you use this data? Studies demonstrate that the conductance is predictive of your battery's state of health. Since conductance is directly related and very nearly linear with the time discharge capacity, a reading of the percentage of a known conductance reference value is a reliable predictor of a capacity test result. An example of this with easy numbers for understanding is as follows. If the rated conductance of a battery when it's first delivered is 10 Siemens and its time discharged is 20 hours, if after 1 year of operation you test the conductance and it measures 7.5 or 75% of the rated conductance, that means that your time discharge is now 75% of what it was when it was delivered to your hospital. So being 20 hours when it was delivered, 75% of that would mean that your discharge time is now 15 hours. What you want to do is record and evaluate the values that are obtained on these monthly measurements for each maintenance-free battery. To make this process easier, you should create a numbering system or assign asset tags to each one of your batteries for record keeping. Now back to lead acid batteries. This is measured by performing the specific gravity of these batteries. To perform the specific gravity test of the electrolyte solution, which is also required on a monthly basis, a hydrometer is used to measure that specific gravity in each cell. It's a tool used to measure the density or weight of a liquid compared to the density of an equal amount of water. A lead-acid battery cell is fully charged with a specific gravity of 1.265 at 80 degrees Fahrenheit. For temperature adjustments, get a specific gravity reading and adjust to temperature by adding 0.004 for every 10 degrees above 80 degrees Fahrenheit and subtracting 0.004 for every 10 degrees below 80 degrees Fahrenheit. A battery's specific gravity is a great way of measuring the battery's state of charge. This is because during a discharge, the specific gravity decreases linear with amp hours discharged. Another example using easy numbers for understanding. If your specific gravity reading when the battery is delivered to you is 1.265 or fully charged, and the amp hour rating is 10, if after a year of being installed you measure a specific gravity of 0.9488 or 75% of the original specific gravity, then you have 7.5 amp hours calculated or 75% of the original 10 amp hours. You're going to record and evaluate the values obtained on a monthly basis for each battery, and again, to make this process easier, you should create a numbering system or assign asset tags to each battery. Now, talking about batteries, I just want to state again that according to NFPA 110, year 2010, section alpha 0.5.6.4.5.1, the hospital is required to replace lead-acid batteries used for generators every 24 to 36 months. Thank you.